Hello there and welcome. Today we're going to be building up a pump assembly for a high-performance 4L60E. The transmission itself is actually being built by the customer. He's got a 2008 Chevy Colorado that's LS swap, making about 700 horsepower, and it's set up as a pre-runner, so a lot of use off-road, desert racing, and things of that nature. So he had asked me to go through the pump completely from start to finish, get it 100% brand new and basically better than new, and take care of the valve body as well. And the reason for that is, he's very mechanically inclined. He basically had built this truck entirely himself, but when it comes to the transmission, he, like many others, doesn't have some of the very specialized tooling and equipment needed, for things like vacuum testing and bore reaming and machining and things like that. So we'll go ahead and tackle this, build it up from start to finish, and I'll walk you through all the different tools you're going to need, and then just show you step by step what all goes into building up a 4L60E pump. I mean, you can follow these same procedures for even a stock to mild performance build. Some of the parts may not be necessary for a build like that versus something like 600, 700, 800 horsepower, but procedurally and the things that you want to consider are going to be largely the same no matter what power level or application you're dealing with. And this is true of really all pumps and valve bodies and really all transmissions. So we'll get a little bit closer to the bench. We'll cover tooling, then part selection, and then we'll go ahead and get started. So let's talk tooling, supplies, and equipment. Now, I initially filmed a version of this prior to actually putting the pump together, but as I was going through the assembly process and performing the different tasks and videoing all of that, I realized I was reaching for things that were not initially part of that tools presentation, so to speak. So as a result, I realized that I wanted to give you guys a true, accurate, and complete picture of everything you're going to need. So I decided to film this segment after the fact and basically put everything on this bench other than the shop press and the vise that I used to put this pump together, test it, and perform all the different tasks associated with a comprehensive pump assembly process. So I have things somewhat broken out into broad categories. We have specialized equipment, basic hand tools, transmission specific hand tools, power tools, supplies, and miscellaneous. And so we'll kind of start at the left side of the bench and work our way right. And again, this is literally every single piece of equipment, tooling, and supplies that I used other than the shop press and the shop vise, which you're obviously going to need one of each if you're going to do this. So here we have a comprehensive reaming station for valve bodies, pumps, and anything else that would otherwise require a reamer to be reconditioned and restored to serviceability. So the centerpiece of this is the Sonix holding fixture and base plate along with the alignment jig. This is sold as one piece by Sonix, and I can't remember how much I paid for it. It was maybe about 7 or 8 years ago that I bought it, around the time it first came out. But needless to say, unfortunately, it's not cheap, and it's not going to be something that you're going to find in a do-it-yourselfer's garage or home shop. And it's frankly not worth the money investing in unless you're going to build a lot of transmissions, doing a lot of valve body and pump work, and at that point, you're a full-on transmission builder. This is part of a whole deal where I have a sink, distribution or dispensation system for the cutting fluid. The cutting fluid itself is kind of stored in a little solvent tank, and it's got a pump, and it pumps the fluid into the workpiece or the area that we're going to be reaming. So that way I have a steady supply of fluid as I'm moving the reamer through the bore. Alright, we're going to be using a Sonix reamer. This is going to be 77917-TL. Alright, this reamer set will service all 700R4, 4L60Es, and 204R pressure regulator valve bores, oversizing that bore for the installation of the respective oversized pressure regulator valves for each of those transmissions. The 700R4, 204R, they take the same valve, and then the 4L60E obviously takes a different valve, but the bore diameter is exactly the same for all three transmission pumps, so this will work with all of them, or for all of them. Again, not cheap, and this particular set is on the less costly side relative to other Sonix reamers for other transmissions. I want to say this set was maybe 175 or 200 bucks, somewhere in there. Don't quote me on that. I don't keep track of all the prices I pay outside of my bookkeeping, so I don't have it memorized. But to give you some idea of how ridiculous these things can go when it comes to cost, Ford E4OD 40100 pressure regulator valve reamer set is in excess of $600 just for the reamer kit. So anyway, that's what we're going to be using. So we'll kind of talk through hand tools and other, kind of specialized manual items. So I have a dial caliper here. It's not really used in assembly, but I have it just because there's always opportunities where you need to measure the diameter or thickness of something, so it's something to have on the bench. A marking tool, because I like to make a mark whenever I torque a fastener. And then you're going to want a pencil with an eraser, obviously to record vacuum test results and make other notes, but also you're going to need something to plug the little orifice in the pressure regulator valve so that you can derive a vacuum reading when you go to test it once you ream the bore out there in the pump cover or stator support. Alright, so for manual hand tools we have a torque wrench. This is capable of giving you a resolution down to 35 inch-pounds, I believe. It goes up to 50 foot-pounds. So we have two sets of fasteners that we're going to need to tighten up, and we'll ultimately take loose, then tighten and torque. They are the Torx 27 stator support to stator flange bolts. So the stator is pressed into the stator support, and then you have the three bolts, securing it. So you're going to use the Torx 27 along with a adapter. If your T27 is 1/4 inch drive, I have a 1/4 inch to 3/8 adapter. And I'm going to use these things in combination with a heavy hammer and a manual impact driver to take those little fasteners loose initially. And we're going to take the stator support to the shop vise on another bench, secure it in the vise, and then go ahead and pound loose those three Torx 27 bolts. You could use a battery impact to do it, but I'll be honest, my technique is less than perfect, and frankly it sucks, and I have a tendency to strip those bolts out, so that's why I like the manual impact driver. Alright, you have a variety of screwdrivers, a 45-degree angle pick, a punch, and I'll talk more about that in a second, and then you also have a 5/16 drill bit. So this punch is part of a pin punch set that you can buy at Harbor Freight. I want to say the set's like 11 or 12 bucks. And this punch is 370 thousandths of an inch in diameter. And what you're going to use this for is to aid you in aligning the stator and stator support using the alignment dowel location in the stator support. So when we go to press the stator into the stator support, we're going to have this pin punch kind of locate the alignment dowel position in the stator support so we can align it perfectly with the stator mounting flange. And then that'll make quick work of what is the riskiest part of that whole process, and will allow us to go ahead and press that stator shaft in and do it once and right the first time. Okay, this larger flat blade screwdriver is going to be used to install the priming spring when we go to assemble the pump body. This little one's going to be used to work valves and check other things. The 45-degree angle pick, we're going to use that to work the one-piece Teflon sealing rings onto the new stator so that we can ultimately resize them and install those two Teflon sealing rings. And then this other flat blade screwdriver is something I always use to remove things like seals or anything else that requires a hammer. And you want a percussion style screwdriver with the steel insert or base so that you don't destroy your traditional handled screwdriver like this with the hammer over time as you're trying to bang on it. Okay, this is a 5/16 drill bit. We use this in combination with the drill so that we can drill the drain back out in the pump body to 5/16 of an inch. You want to do that on all your 700 R4s and 4L60E pumps. They're going to see a lot of high RPMs or otherwise be used in a very intense application. I believe the factory diameter is 1/4 of an inch, but 5/16 gives you a little bit of extra volume or area to move additional volume of oil back into the sump or into the pan, so that you don't have a log jam of fluid pooling in behind the front seal, risking potentially blowing it out. And that would suck. So for 204Rs, I would actually not recommend you go to 5/16. I would recommend you only drill it out to 1/4 of an inch, especially if you're working with a machine pump body, because in that area, the casting, gets a little thin. So if your angle of attack, if you will, into that pre-existing drain back bore is not 100% perfect, you actually run the risk of breaching the deck surface, or I should say the pocket surface, from the other side of the pump if you're going to run a 5/16 drill bit through it. So I'd recommend there you stick to 1/4 of an inch, and the risk for, in terms of breaching the pocket surface from the other side is minimal. All right, we have some supplies here. I recommend you have both types of assembly lube, blue and green. The blue assembly lube is going to be used to lube up your pump pocket and working surfaces, and the bores where you're going to install O-ring boost valves, and the Teflon sealing ring equipped TCC apply valve. So you just want to make those surfaces nice and slippery so you don't cut the O-rings or little seals. And then you're going to use the green assembly lube to hold the non-selective plastic thrust washer that goes on the back of the stator in place, when you're assembling the pump. All right, WD-40 for lubrication of valve train bores once you assemble and after you test, via the vac test machine. You do not want to test the bores when there's transmission fluid or WD-40 or any other sort of lubricant in there, because there's a tendency to give a slightly false or elevated reading. Now, you could certainly argue that it's immaterial, because ultimately there's going to be transmission fluid in all of these bores and all these locations when the transmission's in the vehicle working. But Sonics tells you to test all of your bores dry when you're running the vacuum tester over them, so that you can get, I guess, what they're characterizing as a pure reading. All right, so that's what we're going to do here. We're going to test the pressure regulator valve, the boost valve sleeve to bore, as well as the TCC lockup valve to bore dry. We're not going to have any lubricant when we test. We're only going to lubricate those bores after we test. All right, so as far as transmission specific assembly tools, hand tools, etc., you're going to want to have a precision straight edge along with a set of feeler gauges, and to include a 1 thou, 1.5 thou, 2 thou, 3 thou, 4 thou, and 5 thousandths feeler gauge in your set. You're going to use this to measure your clearance between your rotor, your slide, and the pump body deck surface. And we'll show you how to do that, and we'll get into what the specs are and all that once we get to that point in the assembly process. Okay, you're going to have a pair of snap ring pliers so that you can re-secure your valve trains and install the snap rings for the pressure regulator and boost valve bore, as well as the TCC apply valve and that bore. All right, as far as bushing R&R tooling and seal R&R tooling, you have a Kent Moore set here. This is a bushing driver and a bushing stop. Okay, the bushing stop number is J41778-2. And the bushing driver number, it's a bit faded, but I think I can still read it. It's J41739-1. So that's J41739-1. And hopefully the camera's picking this up, but this is going to be used to remove and reinstall the pump body bushing, and then you're going to put this on the other side of the bushing where it would otherwise go to serve as a bushing stop, so that the bushing is installed to the perfect depth in its location there in the pump body. Okay, this big bushing driver and the handle here is going to be used to pound in the seal for the pump body, and then we have two other bushing drivers here. These are for the stator shaft bushings. We're going to be installing a new stator, so I'm not actually going to use this bushing. Normally I would take the old bushing out, put a new stator bushing in there in the rear. I'm sorry, in the front. This is for the front. But we are going to use this bushing driver to install the rear stator shaft bushing, because when you buy a stator shaft in the aftermarket, it'll come with a rear stator bushing, at least for these transmissions. But the rear stator bushing that the company uses is the narrower type, and we're going to install the wide type. Alright, so here's our sizing tool for the two one-piece Teflon sealing rings that go on the stator. This is literally the last task we're going to perform as part of the assembly process. So if you don't have this tool, not to worry. You can go ahead and use 700R4 scarf cut Teflon sealing rings at that location. There's basically no difference whatsoever, at least in my experience, between the one-piece white Teflon sealing rings that require a sizing tool and the scarf cut sealing rings that do not require any tools to install whatsoever. No difference in performance and sealing integrity potential. It'll work no different than the other type that you need the tool for. All right, you're also going to need some means to support the pump body when you go to marry the stator support assembly to it, to allow for the stator shaft room so that it can slide on through. And then you're also going to need a means to align the two halves so that they are 100% perfectly aligned all the way around. If you don't have a specialized purpose-built tool, you can use a giant hose clamp from a hardware store. That's perfectly fine. As long as you get those two halves perfectly aligned so that that pump will install into the pump bore in the case without any issue, that's really all that matters. All right. I also have a checking tool here so that I can confirm or deny that the rotor spins freely once the pump's fully assembled. So if you don't have this tool, just use your torque converter, and either way you're going to insert this end of the tool. This tool services 4L60Es and 4L80s, or I'm sorry, 6L80s, and you'll go in and you'll spin it a whole bunch of times just to confirm that the rotor's not binding up or nothing's catching, nothing unusual is going on that would lead you to believe that there's some sort of problem with the assembly. Every once in a blue moon, if you're installing new pump vanes, you'll find one of the vanes is maybe slightly too tall, and that will cause the rotor to bind up. So when you go and do your clearance check with just the bare rotor and the slide, no slide support or support O-ring, and no rotor guide, you'll confirm or deny right then and there that everything is within spec and that the rotor and slide can move freely, so that you know that once the pump's assembled and you put it on either your torque converter or checking tool, if there's a bind up, it's not associated with the rotor or the slide. It's something else, and it's usually the new vanes. All right, power drill for, like I said, drilling the 5/16 drain back hole. Plus we're going to use this in combination with the reamer to go ahead and ream out the pressure regulator bore in the pump cover. And then if you want a battery impact to zip bolts down or take bolts loose quickly once you've actually broken them loose using some other means. All right, the last bit of tooling we'll talk about, or I should say equipment, is going to be the Sonex vacuum equipment itself for testing. So you have the tester, and then you have your air pump. I don't know what the flow rate of this pump is. I think it's somewhere 3.5 to maybe 4 CFM, maybe 5. I don't know. I bought it at Harbor Freight years and years ago. But anything in that general range should work for you. And then the tester itself is the block with the gauge along with a test plate and little gasket. And then you have two leads that go, one to the test plate or block and then the other to that pump. And that's what you're going to use to perform your vacuum testing. Now, there's plans and specs and information online available to build your own vac test equipment, kind of like do it yourself. I'll be honest, I think if you're a do-it-yourselfer, that's a great way to go. But for a transmission builder, I mean, at least for me, I'll just speak for myself, not anybody else. I'm very poor at do-it-yourself tool making, so I just buy the equipment that's purpose-built and designed where all the homework and engineering's already been done. And for me, it just makes for a much more efficient way to go. Unfortunately, I don't have time to, build the tooling myself. But for a do-it-yourselfer that maybe is going to do 1 or 2 of these, or just once in a blue moon, but you still want that added assurance, that quality assurance baked into your own process, definitely look up the instructions online to see what what's available as far as building your own vac test equipment. All right, so I know it's a bit long-winded, but like I said, I wanted to make sure you had a comprehensive understanding of all the tooling and equipment that you need in order to properly and completely, from start to finish, build up a 4L60E or 700R4 pump assembly. So now we'll talk through all the parts we're going to be installing and then proceed to the assembly process. That should cover tooling and the parts, and you can kind of see them already on the bench. We'll just go over them real quick. So for our pump body, we have a CK Performance billet 13 vane rotor, a factory slide, and then your front seal, your Teflon coated bushing from Sonex. This is the pump body bushing, goes right here. And then we're also going to install Transgo's unbreakable pump ring kit. for applications that where engines are revving 5,500 plus RPM. All right, new set of pump vanes, pump perimeter O-ring, rotor guide, 13 vane, and then for the stator support, we're going to have a brand new stator. We're going to install that. You'll see that process. This one's looking a little worse for wear. And then for our hydraulics, we're going to have an oversized pressure regulator valve. So we're going to put this casting onto the fixture and ream it so that we can install this oversized valve. These oversized valves on average are about 1/1000 wider at the balance spool end and through the relevant part of the valve that gets reamed in the casting compared to a factory valve. Whereas the transgo drop-in valves I think are I'm going to say 3 to 4 10,000ths wider. All right, and we're also going to install a TCC apply valve from Sonics that has a scarf cut sealing ring that seals off that bore completely, along with a boost valve kit with O-rings. So these are all the rest of the small parts, pivot pin and spring. We have a set of transgo pressure regulator and bumper springs, the slide support O-ring for the slide, the little filter, I have to find an O-ring for that, and then your little snap rings and valve stop for the apply valve for the TCC. All right, so I think that covers it. Let's go ahead and get started. First thing we want to do is remove the stator shaft from the stator support. We want to start on the stator support first, and then once all that's done, we'll work our way to the body and then put them both together and be done. Okay, so we have the stator support assembly chucked up in a vise, and I have like a fairly thick towel to protect the machine surface. So all we're going to do is just bang on the bolts with the impact driver until we break each one of them loose. So this is a Mac Tools impact driver, 3/8. In fact, let me get a socket extension because I'm getting a little too close to the stator there. Not that I want to reuse this, but it's also not a good idea to smack into it. So all you're going to do is hit as hard as you can while twisting counterclockwise. And that breaks it loose right away for you. Alright, that one wanted to fight. My guess is if I went at it with a regular impact, I probably would have stripped out the fastener head. And then you could just remove them with an impact if you want, or use the manual impact to take them all the way out. All right, now we'll go to the press and press the stator shaft out. So you want to set up your press plates so that the gap is such that it straddles the mounting flange for your stator, okay? So you obviously don't want to get caught up on one of the sides. And then from there, all you're going to do is set up some tooling and just simply start pressing it out. So line it up as best you can. I gotta scoot this just a little bit to the right. Alright, what I'm doing now is double checking, make absolutely sure that I'm not gonna, interfere with the stator support mounting flange, or, it's not caught up on the flange or any part of it before I start removing the stator shaft. All right, once you have it out, just check the area where the stator shaft went. Make sure that there's no gouges, no cracking, nothing unusual, nothing that would lead you to believe that you broke the casting. It's a good idea too, and I didn't think about this, but it's a good idea to actually heat the stator support up, especially when you're going back with it on, you know, reinstalling the new stator or your existing stator. For whatever reason you had to take it out. That basically prevents any cracking that might occur from press force on the casting. Okay, we have the stator support here on the fixture, so what you want to do is simply align the bore here for the pressure regulator valve with the opening here, and then we'll go ahead and remove our reamer kit. So this will come with the reamer itself, a reamer guide, and a set of instructions, and that's basically it. Just take the reamer out of its tube. There you go. And then the reamer guide will insert into the bore after the reamer. So you'll actually take the reamer, situate it in like so, and then install the guide with the stem, or the inset if you will, or setback, right over top of it. And then you just want to check to make sure it's fully seated, and then line up your reamer with the opening here in the fixture. And then what I'll do is I'll take a very large block of aluminum, set it over the casting. You're not going to hurt anything with the surface as long as you're using aluminum. And then you're going to need a drill. I didn't mention that in the tool segment, but you're also going to need a high torque variable speed drill, and then you're going to want a beefy clamp as well to secure this thing to the fixture. I actually use 2 clamps. I'm a big fan of 2 clamps. Sonics has a video where they show you how to do, you know, they walk you through reaming a valve body and whatnot, and they have 1 clamp shown, but you know, they've designed this, you know, all this tooling to work with just 1 clamp, but I'm a big fan of having 2. 2 is 1, 1 is none, right? So the reason why I like 2 is because it gives me that extra assurance that this casting absolutely will not move when I'm reaming. That would be a catastrophe if so. All right, and while it would appear to be common sense, you want to make absolutely sure that neither end of the clamp is actually on the casting itself. Okay, you want the bottom side securely mounted to the underside of the fixture or the base plate, and then of course you want the top, the adjustment screw, secured to the aluminum block. You obviously want to make sure that your circuit is exposed. We're going to start pumping cutting fluid right in this area in here, and that will allow us to you know, go ahead and begin reaming. So get this up out of the way. Alright, there's nothing you need to do directly with the alignment fixture itself. This is primarily for valve bodies, but I want to make sure that I can get the chuck in here on the drill, you know, and have unobstructed access without it interfering with, or being interfered with, I should say, with this alignment mechanism. I might be able to, I could stand to probably push this whole thing to the left. So let me finish setting this up. I'll start up the cutting fluid, get that going, and then we'll begin the reaming process. All right, fluids dispensing, so let's go ahead and begin. I took out that rest of that alignment fixture because I thought it was going to get in the way, so. That rotation is good. Get our sleeve back in there, and then we can start reaming. Alright, that should be it. So what I need to do now is, well, first shut off the dispenser. Get this casting in the jet wash so we can clean it off, get all the shavings out of there, and then we'll go ahead and install the PR valve and vac test it. Alright, moment of truth. Casting's out of the tank. Air's on because I had to blow it all, the water out and whatnot, but we need to insert the oversized PR valve and check it via vacuum to confirm or deny that the ream repair was successful. So here's the original valve that came out of this pump. This is a factory valve, and I'll just show you real quick what the diameter is here on the balance spool end. We can get that close without any glare. Alright, looks like it's 365 thousandths of an inch. Alright, so let's go ahead and remove the Sonics valve. And we'll check that. And as you can see, it looks like to be 374 thousandths. So 365. 374. Alright, you're going to want to insert the valve. Make sure it drops on into the bore under its own weight, just like that. Okay, if it's getting hung up, then that means that the ream job wasn't as, it didn't open it up as wide a diameter as it should have. Alright, so I'm going to turn the machine on, want to calibrate it. I'm going to stick here the test lead into the calibration port. Then when we turn the machine on, we want to see a steady 5 inches of vacuum. I guess it would help if you could see the gauge. There you go. And then there's a calibration port here on the side of the block where when we put our finger, the needle's going to jump up to somewhere between 20 and 30 inches, and when we want to dial it in so that it's reading a steady 25 inches of lift. So here we have our bleed valve and our pump valve, and we're going to use those two knobs on those two valves to calibrate the machine. So I just used this yesterday, so it should be pretty close. So I want to see a steady 5 inches. Looks like that's what we have. We'll go ahead and plug the machine in the calibration port. 25 inches of vacuum. Looks like we have to make a minor adjustment. So to increase vacuum on the pump valve, you want to turn it counterclockwise. Decrease it, you turn it clockwise. And it looks like we're right where we need to be on the high side. Okay. Looks good. Now we're ready to run our test. Alright, so you're going to need a pencil with an eraser, and then you want to have the valves rotated so that the bleeder orifice on the stem is accessible. So I can get it. Just pull it out. I'm going to show you, or talk about something else real quick. So you see these two lands right here? These two lands are vulnerable to wear, and when they do, you burn up your 3/4 clutch. It's a, not often talked about, but very common underlying driver behind burnt 3/4 clutch. Okay, if this is burned real bad, you'll start, seeing broken rotor and slides, just failed pump assemblies. All right. So now we'll go ahead and insert it. We need access to this little orifice here on the stem. That's what we want to have so that we can plug that with our pencil eraser while it's under test. All right. All right, we'll get our test block with our little gasket. And what we want to see is somewhere ideally between 18 and 24 inches of vacuum. 18 is like a bare minimum on a freshly reamed bore. Any more than 24, it risks, you risk bind up in the back of the bore. All right, it's pulling vacuum already. So about, I don't know, 3 inches or so. Let's go ahead and plug. We got 24 inches, 24, maybe 24 and a third. Something like that. Let me see if I can hold that there and then zoom in on the gauge so you can see it a little better. Alright, hopefully that's coming through crisp. I mean, it's hard for me to tell, to be honest, but that's the vacuum. Alright. So that tells me the reaming was successful. And you want to make sure that when you test any bores for vacuum, for sealing integrity, you do all your testing with dry castings. So in other words, you assemble everything dry, and then you do your testing. And then after your testing's done, you can shoot WD-40 into all the bores and then work the valves manually with like a screwdriver to lubricate them, and that'll get them ready to work once the transmission goes back in the vehicle. All right, let me get this valve out of here. All right, so now what we need to do is install the stator to the stator shaft, and for that we need to go back to the press, and I'll show you how I use that drift punch to make sure everything's aligned. Okay, just want to grab our alignment pin off of the other stator so that we have it available. I got to clean it off, it's a little dirty, and then we'll go ahead and press this in. Now, one thing you want to do, as I mentioned earlier, is it's a good idea to heat this up. Sometimes, I'll say most of the time, isn't necessary, but it's a good way to mitigate any risk associated with a press force. Where if this is ever so slightly cocked sideways, and it may not even be perceivable by eye, it will potentially fracture the casting. So you don't want that. All right, so what I've done is just put an old shirt to kind of prevent the fresh machine working surface from getting scored up. And then I have my drift here. And then what I'm going to do is I'm just going to insert it and align it so that it is centered as much as it can be centered in the little bore here for the alignment dowel. Alright, now that I'm reasonably satisfied that it is, I'm going to go ahead and get my press tooling so that we can start lowering the ram. And what I like to do here is I'll press it in, stand over here to get as much of a kind of bird's eye view of it as possible to make sure that the stator is perfectly square, or as much as I can possibly get it. And then I'll go ahead and press it in just a little bit part way until I can take it out and eyeball it. Because if you press it in a little bit and you can see it's cocked sideways or something, it's very easy to fix it before you go too far. And this thing wants to sway a little bit, and I'm not quite centered, so I want to make sure I do that. Make sure I get centered. That tool, get it out of the way. Right over top of it. You should flip this around. And make no mistake, this can be tedious and it can be tricky. And it's okay to take the extra time. I mean, yeah, it's not great for videos, but you know, if it's your job, you know, you want to do it right. And preferably you want to do it right the first time. You don't want any problems. Alright, I'm going to check for alignment. Take it all the way out. Put it all the way in. It appears to be aligned as it needs to be. And so now I'm going to start pressing in. Now I'm going to stop. I'm going to check alignment again. And at that point, assuming you're aligned, assuming everything's good with your, you know, your little checking tool here, just press it home. Don't waste any time. Get it nice and flush. Release the ram. And then we'll see if we're aligned here. I know we're aligned on our bowl holes, but let's see if we're aligned on our pin. So this is kind of a gnarly end there on the one side. So and then you could use, you know, something to knock it in, because it's not going to just drop in. There it goes. Check bowl hole alignment. Appears to be good. And then check working surface. Make sure you didn't foot it. No scoring, no scarring. Alright, let's go back to the bench and finish assembling the stator support. Alright, so you can use assembly lube, transmission fluid, and or WD-40, or you know, any combination of those things to finish assembly of the stator support. What I'm going to do is, because I want to record all my values for vac testing, so I want to do the boost valve as well as the TCC valve. You have this location, this location. I'm actually going to install everything dry at first, other than put assembly lube here in the bore for O-rings. And then at that point we'll do vacuum testing for the final time, record our results, and then from there I'll lube up the working valves with WD-40. Alright, so here's the original valve. We don't need this, get it out of the way. Unless we accidentally install it, that would be an absolute disaster. So here is our pressure regulator valve. I think we were like 24.5 as far as final working vacuum, so we're just going to install it. And I'm not going to vac test it again. I mean, there's no real reason to. There we go. So like I said, you want to make sure it does drop in under its own weight once it's perfectly aligned in the bore. You know, if it's going cockeyed, you know, whatever. Once we have all the valves in, I'll go ahead and install the bolts for the final time and put the sealing rings on, and then the stator will be done. I mean, you can put these bolts in now if you want. You know, the order that I'm doing things in is not like required. I mean, you can do any of this stuff in any order. In fact, I would actually recommend that you not machine the stator support half prior to installing your stator, because I mean, if you know you accidentally nick this up, you know, you've ruined a perfectly good stator, especially if you've already reamed it. So you know, I'm not perfect obviously, and so this would be a good takeaway for you when it comes to the order of operations, to learn from maybe a potential mistake I made here when it comes to you know, what order I did things in. Alright, so we have our boost valve. Get this so you can see.
And then we have our springs. So first thing I'll do is lube up the inner bore here. This will not affect your vacuum reading because you have O-rings, and O-rings are ultimately going to seal off the circuit to the tune of nearly 100% or straight up at 100%. I mean, you'd be surprised where air can, get to and go through or get past, but for the most part, it's an at or near perfect seal when you're dealing with O-rings. So there's the little valve in there. And Sonex does give you an extra O-ring. This sleeve only takes 2, not 3. But I'm glad they do that, because every once in a while I will break one of these O-rings, just, either being careless or because the O-ring itself had hardened in storage. Maybe this particular or that particular valve kit did not get sold until long after it was actually produced, or maybe it was exposed to unusually hot conditions, or whatever the case may be. And so it's good that they have extras. I mean, I have tons of these, to be honest. And yes, every once in a while I will need to reach for an extra one, because I'll break the O-ring. All right, let me go get my snap ring pliers. All right, lube up your O-rings as well. So you got the bore lubed up, you got the O-rings lubed up, and that should cover you. I'm hoping that there's not too much glare here. The only reason I'm not using any of the other benches is because they're all occupied with transmission parts. All right, if you're going to break an O-ring, it's probably going to be right here when you're trying to seat the boost valve in place into the pump. That's probably when it's going to happen. All right, you want to see, hear, and feel the snap ring seat into the groove. All right, take you a flat blade screwdriver and just work the valve. You should not feel any kind of binding or resistance or anything like that. And it should return to rest position under spring tension. If it binds up, then you got to take it out and ream it, run the reamer back through it, which would suck. All right, TCC apply valve. The boost valve part number is what? Where's that? So this is the boost valve kit. It's going to be 77898E-K. And then the oversized pressure regulator valve is going to be 77917-07. I don't think Sonex makes a drop-in valve where no reaming is required, but I could be wrong about that. I've not seen one. I've never used one. It's the Transgo drop-in PR valve is my go-to for most applications where the vacuum reading here at the balance end is either 11 inches or greater, but not in excess of 15 inches. If it's 15 inches, then you technically don't have to do anything, but you can certainly shore it up, and if you install the drop-in valve, you get another 3 or 4 inches of signal. And that's how much that is worth. If you're at like 8, 9, or some single-digit number, then you really need to ream the bore or replace replace the casting. All right, so here's going to be your Teflon sealing ring. Let's see, this is one piece, or is it scarf cut? That's one piece. How about that? All right. Do the best you can to not get it all twisted like I did. And then you're going to need to massage it by hand into the groove, if so. Yeah, this one got all twisted up. Usually not a big deal. I don't know of a sizing tool that you could use if you get it really spread out, but it's usually not necessary. I mean, most of the time you can bring it back to where it needs to be just using your fingers. Just like that. And then this valve's design is consistent with the second design TCC apply valve and the later 4L60Es. It uses just a single spring. Alright, we'll go ahead and put a very healthy liberal coat of lube on there. All right. Actually, let me see if I can get a little bit of lube in the bore itself. Just coat the inner diameter and the inner walls where that Teflon sealing ring is going to have to pass. And then all I'm going to do is very lightly tap until I could feel it bypass, meaning the sealing ring bypass the opening of the bore there. Alright, now I'm fully seated. The spring is, it's not bottoming out, but there's spring tension. So I know I'm in the bore as I need to be. Put our valve stop and then our snap ring. So just like the other valve, you want to make sure that your snap ring is fully installed into that groove. And you can test it. Eyeball it. Good to go. Wrong O-ring. I have to go get an O-ring. Recordation of vac test results. So this is the template I use. This first page is valve body, so you can see pretty much everything passed and passed with flying colors. We put a whole bunch of Sonex parts into the valve body as well, and a fits-all TCC regulator valve to prevent P1870 and seal off that board completely. So, valve body's good to go for what what the customer's going to be doing with the transmission. It'll be nice and healthy, and everything sealing very well. All right, I'm going to record the PR valve. Record that 24.5. All right, so we'll do the apply valve and then the boost valve. Turn the machine back on. And the boost valve is going to be this fish-shaped casting or, depression there. And you're going to have to plug an orifice on the other side. You just want to make sure you have your gasket fully covering the fish. So here's the hole right there, second one in. That's given us 22, just shy of 22 and a half. So I'm going to record that as 22. All right, for your TCC apply inboard, you need to plug this orifice right here. And I realized you couldn't see the, could not see the gauge. So we'll test the boost valve again so you can see it. Once again, bad camera work on my part, I apologize. So what is this? 23 and a half? 23? I'm gonna just record 23. I can always change it when I look at the footage. I have to basically get in your way to tell for sure. I mean, either way, it passes. Alright, so when you test the outboard position here on this little orifice, you need to put a finger over the end here to seal the circuit. On a regular valve. On this valve, you don't have to do that. It's perfect seal. That's right. You don't have to do that on this valve. Alright, we'll go back to the fish. So there's our boost valve. And 22, just shy of 22 and a half. All right, so stator half is healthy. So I'm just going to record what exactly I did with it. All right, get that out of the way. So now what we're going to do is install those stator support bolts. And I don't know if the ATSG manual actually has a specification for these things. I'll have to look. It's been a while since I've looked at it, but I generally torque these to anywhere from 90 to 100 inch-pounds. And what I'm going to do is I'm going to put a little Loctite. I mean, it can't hurt. It's not like it's going to prevent anyone from removing these bolts again using the impact driver, whether it be me or somebody else, for whatever reason. But it's just good practice to make sure that you're buttoned up in here, especially on a high RPM situation. Not that these actually see RPM. I mean, to be clear, this doesn't rotate in the bore or anything, but like I said, it's just, it can't hurt it. Little extra insurance to make make this area good to go 100%. I'm gonna do 90. See how that feels, and then if it feels like it could take more, then I'll bump it to 100. That felt perfect. I mean, is this marking necessary for these 3 bolts? No. I just like to do it. Okay. So, the stator support assembly is completely done. The shaft itself came with new bushings. Sonic's rear bushing, normally that's what I would install here. Unfortunately, for whatever reason, their bushings have been out of spec as of late, and they'd be way too tight for the input shaft. And so I don't want to have the customer who is, you know, not in the same state as me to just, you know, try and go and install this into the, you know, onto the input shaft and try to seat it when he's finishing up the transmission, only to discover that it won't actually slide over, it's bound. And so, you know, that would be a problem. Let's take a look at this bushing. I want to see if I have a wider bushing. So notice the bushing on the left is a little bit wider than this bushing. And I think this bushing is the same as this standard factory spec bushing. So let me yank that out. I'm going to seat this one and then we'll be done. All right, when you think you have it all the way in, just check it real quick. You want it to be just below the bevel, so we have maybe a smidge, I'll say a smidge to go. Just a smidge. All right. Yeah, it looks to be about right. Okay. So, you know, with the bushing snafu resolved, we can finish this thing up. So all we really have to do at this point is go ahead and install our sealant rings. And I'm actually going to save that for the very end. All right, we're here at the press, so we have our press tooling so that we can R&R the bushing here in the pump body. So this is a typical Teflon bushing. These are perfectly fine as well if that's all you have access to. Even in high performance applications, you don't necessarily need to install the Sonex bushing. It's just a nice to have. So let's get it out of the baggie. There it is. So part number for this thing is going to be 77005T. Alright, and then we have our bushing R&R tooling for the press. This is going to be J41778-2. This is going to be our base or our stop. So when we install the new bushing, that's what we're going to use. And we have the bushing driver itself. It's J41739-1. And I mean, I know that's heavily worn off. This goes like this. We're going to get this out of the way. We'll bring that back when we go to install it, the new bushing. Alright, you can use Loctite as well on here, but it's usually not necessary. Let's go ahead and set up our tool, get our bushing positioned. You're going to install it like this. Make sure that you're fully seated there on the stop. Get the bushing as square as you can get it there in the bore. All right, looks good. All right, let's go back to the bench. All right, incidentally, maybe you noticed it, maybe you didn't, but I completely forgot to wallow out the drain back to 5/16 of an inch. Something I do pretty standard on all these pumps. 700 R4s, 4L60Es. I would not advise you to go 5/16 on a 204R. There's a small chance that you can actually break the deck surface here, or the pocket surface, from the other side going through the bore with 5/16. Those pumps are a little thinner in this area than the 700Rs and 4L60Es. So anyway, just wanted to get that out of the way. So first thing we need to do is install our new seal. So let me go ahead and get the driver and we'll get that installed, and then we'll build up the pump body and then marry it to the stator support. Alright, like the bushing, you want to get the seal square there in the bore as you can. And then a few smart smacks is really all it needs. I just want to eyeball it, go all the way around, make sure it's fully seated, and then that's basically it. Alright, so first things first before we put the body together is we want to make sure that our rotor and slide to deck clearance is within specification. So to do this, all you're going to do is you're going to place the rotor by itself and the slide by itself into the pocket. You're not going to put the rotor guide in, you're not going to put the slide support or support O-ring on, you're just simply going to have the rotor and the slide in there. No springs, nothing. And then go ahead and grab your straight edge, and what you'll want to do is first, even before you start any measuring with feeler gauges, just rotate the slide back and forth and make sure it's not coming into contact with the straight edge, because if it is, then that means that the pocket was cut too deep. Okay, as you can see, there's no contact whatsoever being made between the slide and the straight edge. Alright, now you're going to do the same thing with the rotor. Okay, the same test. You want to make sure there's no interference between rotor and deck surface, and you know, it's not going to come in contact with your straight edge, because again, that would imply that the deck was not, or I should say the pocket was not cut deep enough, or the deck was cut too deep. So now that we've established that there's no interference, there's not going to be any problems per se, now we want to see exactly what kind of gap we do have between these two surfaces and this one. So the spec is 1 to 2 thousandths for the rotor and the slide. The book calls for between 1 and 1.5 thousandths rotor and 1 and 2 thousandths slide. In my experience, if you're between 1 and 2 thou for each of these, you're good. Very high RPM applications, believe it or not, it's okay to have a little bit more clearance at the rotor if you're at like 2.5 to upwards of even 3 thou, because that'll give a little bit more oil on each side of this rotor to serve as an intermediary between it and the working surfaces on the castings. So I'm going to start with a 1.5 thou feeler gauge, and I'm going to see what I have. So we'll just kind of come in as shallow of an angle as possible. And it looks like I have my 1.5 thou over here and my 1.5 thou over here. So again, nice and easy movement. Now let me grab the 2 thou feeler gauge. So there's 1.5. Here's 2 thou. Hopefully you can see that. I can't see it on the viewfinder. At some point I'm going to upgrade this camera to something better. I don't know when that's going to be. Alright, this is fitting, but it's dragging just a hair. Alright, it's fitting a little bit more evenly, but it's still dragging a little bit. So I'm going to say if we are at ever so slightly above 2 thou clearance, like maybe 21 10 thousandths, 22 10 thousandths, that's not going to hurt anything. It's not going to make a difference whatsoever. Alright, let's see what kind of clearance we have with respect to the rotor and deck surface. So 1.5 thou feeler gauge. And this gauge is a little bent up, so sometimes it won't go just because, you know, it's got some bends in it, not because it's too tight under there. It's just FYI in case you're wondering. Alright, 2 thou. Alright, 2 thou is okay. Alright, I'm starting to feel some drag though. So let's see if 3000s will slide. And where I'm getting this 2 to 3 thou as being tolerable and even preferred is a couple of comments or posts made by Dana at Pro-Built Automatics, where he talks about actually having 3 thou as like an ideal clearance for anything 5,000 RPM or higher. This is going, but it's dragging pretty good. All right. So this is the bottom side of the rotor and this is the top side. This should be perfectly fine. Again, when at real high RPMs, a little bit thicker sheen of oil or layer of oil, lubrication oil basically, between the rotor and the working surfaces is good. It's kind of what you want. All right, so let's go ahead and assemble this thing. So we'll pull out our transgo and breakable pump rings. So you have a single priming spring, just like later model GM 4L60Es from the factory, and then you have your ductile iron rings. And I had taken the instructions out of the box earlier. Kind of show you. So these are for engines that are expected to rev over 5,500 RPMs, and these instructions are also available on Transgo's website. And then they give you some information, some technical details on what to do with respect to the various parts in the pump here. All right, so first thing you want to do is take your slide, your support O-ring, and your support, install them just like this, and then lay it face down, or face up I should say, on the bench. And then go ahead and lube up your pocket, catch the bushing and the seal, and then all you're going to do is take the body and drop it right over top the slide and slide support assembly. Alright, this way you don't have to worry about that stupid O-ring and support just coming out, falling out. Alright, go ahead and put a ring, and then lube up the back of your rotor. Go ahead and put your rotor guide. And do I have this wrong? Maybe I do. This guide actually only goes in one orientation, so. And these billet rotors, they can be a little finicky too. Yeah, I'm royally screwing this one up. I had it right the first time, but it wouldn't go in because the little cutouts are pretty tight, tighter than a factory rotor. All right, then just go ahead and install it, and grab your pump vanes. Brand new vanes, you just install them like this with the long axis facing up and down. If God forbid you're reusing vanes, you want to make sure that you install them in the correct orientation as far as what faced the rotor and which side faced the slide. And you can easily tell because there'll be little witness marks at the top and the bottom of each vane on the side of the vane that faced the rotor. And you want to put them back in like that, though I've seen them in both ways, where I could see witness marks on both sides, knowing that at least one other person that's been through the pump reused the vanes and they didn't put them back in in the orientation that they should have. But I mean, these things are, I want to say, between $5 and $8 for a set, depending on whether it's a 10 or a 13 vane pump you're working on. And I don't understand why people don't buy new vanes. All right, now It's up to you. You could have done what I'm about to do next first. It really doesn't matter. But as long as you install your slide support and support spring in here before you install your pivot pin and spring in here, you'll be fine. In here, not the friggin' bolt hole. Sorry, I'm somewhat distracted, you know, a little disgusted about something else. I don't want to get into it, but something transmission related, something new parts not working or failing shortly after installation, you know, OEM parts, not GM, another manufacturer who shall remain nameless. Okay, to install the priming spring, you just basically do what I just did. Very simple deal. And then install your top ring. Okay, make sure everything is fully seated. And then go ahead and lubricate the top of the slide, rotor, and ring. And then bring the pump body onto your, you know, whatever you're going to use to support it. Alright, so now we're going to go ahead and marry the stator support assembly to the body. A very simple deal. Truth be told, you want to get your alignment tool in position before you put the body onto the support or whatever it is you're using. Alright, and if you wanted to install the slide priming spring and the pivot pin and spring first, that's perfectly fine. That's how I typically do it. To be 100% transparent, I literally forgot to do it. But luckily, order doesn't matter when it comes to those things. Alright, so lube up the working surface on the stator support, and then look for the two bowl holes that are closest together on your pump body. And then match them up with the two bolt holes that are closest together on the stator, and carefully lower it down and see if you've gotten the correct bolt holes. Okay, there we go. Install your bolts. These get 15 foot-pounds. Just thread them in part way at this point. Again, not a bolt hole. Alright, and then go ahead and install your alignment tool. Make sure you have it all the way around, as evenly straddling or evenly across both the stator support and the body. That's going to give you the best chance at aligning it correctly the first time. If you don't have a tool like this, you can use a giant hose clamp. That'll work as well. Some folks have figured out a way to use the case itself as a sizing and, or not sizing, an alignment tool. Sizing, I don't know where the fuck I got that. As an alignment tool to align these two halves. I wouldn't recommend doing that because there's an ever so slight interference fit between the outer perimeter of the assembly and the pump bore and the case in most 4L60Es and 700R4s. So, you know, there's really no way around the tool in my mind. Alright, what I'm doing now is I'm trying to center everything so that when I cinch this down tight, everything is aligned from a pump to case bowl hole location as well as the two halves themselves. So 13mm socket. Alright, so I'm going to go ahead and torque these up. I was just checking to see if this marred up the paint. I should have put like a towel or something in between. So 15 foot-pounds is all you need. So every other bolt until you get to all of them. All right. So let's go ahead and check, make sure that our alignment's still good. So the easiest way to do that is just to run your thumb all the way around the circumference of the pump, and all you're looking for is differentiation on this side and this side. If this side seems proud or this side seems set back, you obviously know that you need to take loose your bolts and try it again. Okay, this appears to be good to go. All right, let's get that 3-tab washer. In fact, he may have that with the rest of the transmission bits, but I don't think I had one coming in, so I'm going to put another one on just in case he does not have one. All right, let's go ahead and check the rotation, make sure everything's good in that respect. We have our checking tool. Okay, I'm just going around a whole bunch of times. Feels perfect, no issues, nothing weird, nothing binding up. I mean, that's all you really need to see. All right, last but not least is our pump O-ring. At least as far as the body is concerned, then we have to install the sealing rings for the stator. Getting a little excited, a little prematurely there, so I'll have to do the sealing rings. So 45-degree angle pick, and then just carefully work the sealing rings over each of the respective grooves and into their location. I mean, it's pretty straightforward deal. And then do what you can to resize it by hand. And a little assembly lube on the sizing tool. All right. You're probably going to need a hammer to take this sizer off. I mean, I'll try to see if I can get it off by hand. It's not coming off, my hands are slippery. Okay, that's perfectly normal. It indicates that the tool's doing its job. Okay. Now the pump is 100% assembled. There's nothing left to do with it other than keep this in place, and if you're rebuilding the transmission at this time, I would recommend you keep this on for about 15 or 20 minutes, maybe do something else while this is resizing the sealing rings, because if you take it off and you leave it off, the rings will actually kind of expand or spring back, if you will, just a little bit, but enough to where they'll catch when you go and try to install the pump, you know, over top the reverse input drum and seat the stator here in the journal. It won't let you bypass. It's usually the top sealing ring that gives you trouble. It won't let you get past that sealing ring, and if you force it, you'll break the sealing ring. And if you're not doing case air checks, you won't catch it, and you'll have no reverse when you go to try and drive the transmission or drive the vehicle. Once the transmission's installed, drive the transmission. I'm telling you, I'm having a day, and it's probably not going to get much better. Now, when I ship this pump back to the customer, what I'm going to do is I'm going to have the sizer installed probably overnight, and then I'll take it off, and then I'm going to right away tape up the sealing rings so that they don't expand. But if they do, or if there's a problem, I'm going to include a set of scarf cut sealing rings in case the customer needs them. And because I don't know if he has a sizing tool for this, you know, for these rings. So this way, again, further mitigates risk to him, so that he's not delayed by having to get either a tool or having to, you know, go source these himself. You know, these scarf cut sealing rings. So anyway, guys, this is the video. I hope it was informative for you. You know, it was a little longer than I figured it would be, but you know, there's a lot to it when it comes to putting a pump together for a high performance application. So wanted to go through every phase of the process, kind of show you what tools you needed so that you know tooling, supplies, equipment, and then take you through step by step at each, you know, each juncture, so that you know exactly what to do, what to look for, things you should be considering, parts you need to purchase, and how to install them, so that when this thing goes back in, it's fit for purpose and meets the need. So anyway, as always, guys, thanks again for watching. If you have any questions, comments, go ahead and leave below. If there's anything else you want me to discuss when it comes to 4L60Es, just put it in the comments and I'll prioritize it as soon as I can. Until then, enjoy the rest of your day or evening. Thanks so much for watching once again, and we'll see you on the next one.